about JavaScript. It's about Java. It's about runtimes. And in my virtual studio here, I have a very exciting guest who I would like to introduce to you and who I would like to learn from. And not just myself, but I think there is an opportunity for all of us to learn a thing or two from Paulo Lopes. You can see him right on your screen. I really hope that you can see him right on your screen, but I will check whether we are live or not a little bit later. So Paulo is here. Can you maybe, say hi? How are you?
Hi, Oleg. Hi, everyone. My name is Paulo, as Oleg just mentioned. I am a core committer of the Eclipse Vert.x project and a creator of a very interesting project called ES4X, because as you know, the most complicated things in computer science is caching validation and naming things. And it's just like Oleg said, it's a bit of Java, it's a bit of JavaScript, and it's a lot of GraalVM in the mix.
Excellent. It's very, very good. Right, I'm just experiencing some slight troubles on YouTube. So if anyone is watching me on YouTube right now and you're experiencing troubles, ping me in chat. Other than that, we'll continue with our usual program. So you mentioned a couple of things there, Paulo. You work on the project ES4X.
Yes.
And as far as I understand, it is also, so ES4X is a JavaScript runtime for server-side applications.
Yeah, that's correct. So the whole idea of the name ES4X is to reuse the short words for ECMAScript for Vertex. That was like the original idea for the name. And the whole project began because Eclipse Vertex is a polyglot runtime, and we already had some JavaScript bindings in the past, but we were relying on Nashorn, which is now kind of deprecated technology if you want to run JavaScript on the JVM. And it started as research, kind of internal research. I cannot really claim it to be like scientific research, but like a research. How could we reuse what we've learned from the past, fix some mistakes, and update our runtime to something more modern? And it was kind of alignment of the stars, if you want to say, because I was still researching on transpilers, trying to convert modern JavaScript using transpilers back to ES5.1, because that was like what Nashorn could run. And suddenly there was this big announcement about GraalVM, which came with another a module called GraalJS that was telling everyone that you could run modern JavaScript on the JVM. So it was kind of, oh, this is interesting. Let's try to align both things and see if we can get it to work together. And that's how ES4X came to be.
Right. So, and we'll get to ES4X, and the whole session is mostly about that. I would like you to maybe say a couple of words about Vertex, because I think that's a very interesting project, and it also, like, in a sense, if somebody doesn't know what Vertex is, can you give us a little bit to understand what it is and how it can
like
power?
In a nutshell, Vertex is a Java library. We don't want to call it a framework. We prefer to refer to it as a toolkit. It's just a tiny library. If I'm not mistaken, I think the jar file is something around 700, 900 kilobytes in size. So it's quite small, and it's a library that gives you all the basic building blocks to build asynchronous reactive applications. It gives you an event loop. It gives you an optimized, easy to use IO library that builds on top of Netty, because we only have like 2 or 3 dependencies. We use native for I/O. We use checksum to do our JSON and marshalling, and that's pretty much it. Like we have optional loggers. So if you look at the list of dependencies, it's quite small. So this small toolkit gives you like this foundation to build asynchronous reactive applications, microservices, and it's quite used in higher level frameworks. So if you want to talk a bit more about it later on, or use cases.
Right. No, I mean, like if you have a couple of names of the project who are using Vert.x, that'd be great to kind of place it in
like
the ecosystem.
if we want to talk about open source, like probably one of the most well known at the moment users of Vert.x is Quarkus. All the I/O is managed by Vert.x, and if you are just talking about Vert.x in general, who's using Vert.x, it's used in financial services. Like we have like known projects on Blue Bank in UK. I think it used to be called Royal Bank of Scotland, and here in the Netherlands we have ING that also uses it internally. So for all these projects that need high throughput and low latency, Vert.x is quite a good fit, and these are some examples.
Nice, very nice. Right, and with this toolkit, you built the runtime for JavaScript using GraalVM. That is
Yes.
A very appropriate usage of GraalVM as a project, and specifically GraalJS. Just recently had a session on sort of the new and noteworthy things in ECMAScript 2021, which GraalVM already supports, and those are enabled by default. So this is a very good, that's a very good match, right? So one project provides you with an engine, with the runtime to run the language, and you're building sort of a framework for the application developers.
Yes. If you want me to say something about it, is the idea was like this was mostly it started as a research project, so I wanted to keep it small and simple. So it was pretty much learning from the past iteration with Nashorn and see how we could improve our usability, and it turned out that it was quite easy to do it with GraalJS.
Right. What I wanted to ask, one thing is that the whole stack, both ES4X and Vert.x, are reactive. How much reactive as the sort of the paradigm for building applications, how much does it influence, or is it just something that is it like a fundamental thing that enables this, or is it just more of a, oh yeah, it's cool to be reactive nowadays and let's do that?
No, it's a fundamental feature. It's like without that feature, we couldn't have built what we have today. So, like because you made more sessions about JavaScript in the past, like the GraalJS engine only allows single thread access to the engine at one time. You can have multiple threads interacting with the engine, but only one can be modifying its state at a time. So this is kind of a limitation if you think how Java applications are built traditionally, with every request has its own thread. So we usually share resources. But if you look at Vert.x, because Vert.x is reactive in the sense of being asynchronous, this kind of it's a good match, because when we say that Vert.x is asynchronous, it means that we spawn one thread per CPU core. So this limits the number of threads that we are running. And because we know exactly how many threads for the whole lifecycle of our application are running at one time, it's easy to map one GraalJS context to one CPU core and then to its own thread, and this creates a high affinity between execution process, GraalJS context, and so forth. So if you are really interested in high performance, you're gonna look in the details of JVM, and you see almost never like locking and no contention, because like there's only like, for example, my laptop currently has 8 CPUs, so I see 8 threads at a time running, and they all are use their CPU capacity is always at the max. It's never like waiting for resources or waiting for other things.
Right. Okay. And also, if I understand correctly, right, there is like this ES4X is not the first JavaScript runtime ever, server-side
No.
runtime ever, right? There are several before, and of course there are some very popular ones. For example,
Yeah.
Node.js, right? We cannot miss Node.js. Well, and then from Ryan Dahl, the like sort of the second generation of Node.js is Dino, and pretty much others. But those two are also reactive, right? In the sense that there is
Yeah,
the
correct.
main thread that does things, and then there are workers which can spawn off additional things, but the communication between those is limited. So there are some common parts, and I assume that enables some sort of the mental pictures when developers who use, say, Node.js, right, like a JavaScript developer for the server side uses Node.js, they feel comfortable in using Node.js. ES4X would fundamentally feel a little bit similar to that, right?
Yes. Well, that was one of our goals when we started ES4X, because before it was very Java build tools centric. That was kind of always like a big step for people just coming from Node.js. With this iteration, we decided to what if we use the tools that JavaScript developers are used to use? So in other words, instead of using Maven or Gradle, what if you tell them like you can use npm to create your projects, to install your dependencies, or even to run your scripts? So this change is kind of the big difference between the old Vertex and the ES4X runtime. And
Right.
if you want to talk about Node.js, there are, or Dino, there are like some fundamental differences. For example, when we're talking about Node.js, we all know that Node.js is one single process per CPU. So for scaling, you need to spawn as many processes as you want for CPU. Well, in Vertex, it's a bit easier because since we are on a JVM has threads by default. Instead of spawning processes that need to do some IPC between them, we just spawn one thread, and we get almost the same kind of affinity. So it's quite interesting. And you mentioned also Dino works more or less like Node.js. The big difference is like the default programming language that switch from JavaScript to TypeScript. But with modern IDEs, I don't really see like why bother. Like I can just pick whatever language I want and just transpile and run it on an engine. So it doesn't really matter.
Yes. Yes. So do you like it's a trick question now. Do you think ES4X is better than Node.js and Dino in some fundamental ways? Like will
Yeah.
if like say 50 years in the future, let's say, and it happened that only one server-side JavaScript runtime has survived, right? And
Yeah.
it happened to be ES4X. So congratulations, Paula.
Thank you.
Now looking back from those times, or maybe not 50 years, maybe like 10, 15, no, like prolonged period of time, right? In 50 years, dinosaurs will roam the earth back again. But in a sense, what was the quality? What were the qualities of ES4X that allowed it to be that winner of that competition?
Well, first of all, I need luck and lots of promotion from the community to get to such a state. But in my perspective, there are good benefits of picking ES4X compared to Node or even Dino. Like the main difference is the performance. So I've been like saying that, well, ES4X uses a thread per core, Node.js uses a process per core. It's all looks quite similar in a nutshell, but there's a big difference. When we look at the profiles and execution profiles of your application, you see that if you profile a Node.js application, you see that two major blocks, like part of your application time is spent on some native code called libuv, and a very tiny fraction of that time shows you that the time was spent on your script. libuv builds on top of V8, which is the JavaScript engine of Node and Google Chrome and even Dino. And the interesting part is that it's quite of interesting VM also as a JIT. However, the JIT will only affect your script because the VM itself, it's a native C++ application, and native C++ applications are not dynamic by nature. So the JIT will only be affecting your script. Now, it turns out that on ES4X, we are kind of in the same situation, but there's one fundamental difference. The difference is that the old runtime, GraalVM, handles both languages, Java and JavaScript, as a whole because of this truffle language. And the JIT will compile everything. So the big difference, if you do a performance profile of ES4X application, you'll see that the JIT will affect not just your script like it does on Node, but it also will affect how your network stack and libraries are working. So it will affect how Vert.x and Netty are performing, and will optimize those to the peak performance of the current environment. And that we saw on the Tech and Power benchmark, and it was kind of a surprise even for me because I wasn't really looking for that. And if you compare the two, you see that we have like a huge difference between running a ES4X application versus a Node.js application. In this Tech and Power is kind of a very popular benchmark on the internet. You can just implement the several tests, and you see here, like on the example you're showing, like this is a very simple test. It's a test where you have an HTTP server that gets an HTTP request and does a SQL query on a database, and you are allowed to choose between Postgres or MongoDB or MySQL. And I chose back then Postgres because we Vert.x already had a reactive Postgres driver back then. And you see the difference. Like, well, let me read. Like, we do 702,000 requests per second on the JVM, so on GraalVM. Because everything is being optimized, while if you go on the next one running on Node, only does 200,000 requests per second. These numbers are quite interesting if you're building applications because it can also tell you that you can reduce your hardware bill, and even your VMs probably can be reduced in size. You can even like have smaller machines to get the same throughput as you would on a Node.
Right. So the Tech and Power benchmarks here are sorted by the language. So there is a filter, and there are a number of benchmarks different here on the top. So out of the JavaScript engines, ES4X ranks at the top, and I think this number here in parentheses, which is 79%, is the performance of the overall across all languages, right?
Yes.
So something like something like, I don't know, Rust or like C++ or whatever people implemented here would be.
There, of course, there are some benchmarks on some native languages that can go closer to the metal, that can be even more optimized, and they will get better results.
80% of the most optimized runtimes is pretty impressive, and this is on the sort of a functional application that is mimicking a real-world microservice. So it's queries a database.
Yeah, it's all on GitHub. If you go on Tech Empower organization on GitHub, yeah, that one. So now you go on frameworks, and then you should have like a list of programming language, programming language.
Let's go to JavaScript.
And there you go, yes, for X, yeah, and then index.js, because that's kind of
oh, so this is our application.
And here it implements all the tests of the benchmark. So I try to even document with what you could read from their requirements, just to make sure that I'm not like following all the rules. And as you can see, like if you are a seasoned Node.js developer, the code will look really familiar, using all modern features like import statements, ES6 modules, and arrow functions, and so forth.
Right. So this looks very, very familiar. This is a normal application. So you create the application and you register like handlers to URLs and then send things. Here's the question though, right? Here's my question. And I want to talk about performance a little bit maybe later down the line, but since we're looking at this anyway, here's, wait, this is something different. We looked at this page. Like, how much do you think Tech Empower benchmarks actually, how reasonable they are? So it is definitely better than a micro benchmark, right? But my suspicion there is that very many frameworks are actually like gaming the benchmark a little bit, like, you know, because if you know that you have to answer like a single query, even if you do the round trip.
Interesting discussions in the past about gaming the benchmark, and I don't want to go like in those words, but I know that I could optimize the results even further. For example, here, when you see on line 26 or 27, when I'm setting all the HTTP headers one by one and doing a stringify, I could just buffer the headers in one buffer and just write the buffer directly on the response, which would still be allowed, but a bit awkward because that's not how you code your applications.
Yes.
And there are some frameworks to do that on Tech Empower. So if you want to talk about how close to reality the benchmark is, it's a bit close to the reality, because it showcases that you sort of a REST API with a real database behind on the different servers. So you're not they do make sure that they use one machine for your application, another machine for the database, and another machine to start the load. So like the testing methodology, I think it's correct. Although the test itself is probably too simplistic, because nowadays we would expect something like HTTPS and some security stuff on front of it to really mimic a real application. But this kind of like kicks the tires of any framework, because, well, HTTP, REST, and databases, everyone does that.
No, absolutely. And security, you can probably get away with some sort of API gateways and whatnot. I have a question here in chat. JAEOL is asking, round 18 is old, 20 is the current round. I see it here as well.
That's
do
correct.
I click on it?
You need to update the links. You can update it.
Yeah, I got the links from the website, so I'm
Yeah, that's
asking.
correct. I need to update the links, and I know that we are number 2 now.
Okay, okay.
And it's all fair. I can even explain the small differences. Um, Just.js is another framework that well, it's attempting to be number one, and they managed to do that. And by the if you look at the framework, basically they picked Node.js and remove all the slow parts, and they only end up with V8. And then they kind of follow the same methodology. They implemented the minimal network stack to run on V8 in JavaScript, and the minimum driver to connect to Postgres. And it's all fair. They are indeed faster. However, it will be more complicated to do like a real world comparison. Say when you say to them like, okay, let's put HTTPS on SSL on top of it, and don't use plain authentication on Postgres. Use some Scrum, which is like the new algorithm that Postgres uses to do like secure communications with clients. Well, then you need to implement that yourself. In our case, well, we just rely on the security of the GVM and where everything is already provided for us.
No, I mean, like
But
I think it's a very very good result nonetheless,
yeah,
right? So
yeah,
it's significantly faster than if you compare it to Node.js, for example,
yeah.
which
Like because
most
those
people would compare.
other implementations are kind of are fair. Like if you look at their code and look at the S4X code, we are kind of playing simple. We're not trying to be always the number one. If you look at the Node.js code on the implementation on Tech Empower, it really looks like how you would implement the application. It's not made to win.
Right, right, and that's very good to hear. As a part of the runtime team, we care very deeply about performance and the benchmarks, and like it's a little bit like you can game any benchmark, right?
Yeah.
If you start to optimize and if you work on optimizing a particular set of benchmarks for too long, then you start like kind of sort of overfit the machine learning
Yeah,
algorithms, right? You
and
start
because
showing
it's
really
a very simple test. If even with native languages, C++ or Rust, if you do link time optimizations, of course, your native code will be even faster.
right. If you there is a question about Java and Vertex, and this is sort of appropriate right here. So the same JOL person is asking, there are Java frameworks that are about 40% ahead of Vertex. Do you think Vertex can gain in on that gap? And whether something like replacing NATI or switching network libraries would be a solution there? Not sure.
Well,
Yeah.
our goal it was never like to be the top of the benchmarks. It just happens to be. The goal was to make like an easy to program API for say if you have to build a NetI applications and you need to work with NetI, let's be honest, it's hard if you really need to know what you're doing. And what Vertex tries to bring on the table is that we can have easier programming model that you don't need to worry about the threading model and the context switches. And I had a very cool discussion a few weeks ago with someone telling me that they built a new team of developers, and because they were having trouble hiring developers, they start hiring JavaScript developers. And when they were introduced to Vertex, like they were like in a few weeks familiar with the APIs because everything felt so familiar. So that was our goal, like easy to program library for everyone.
Right. I'm sold. If you just this is
You'll get
fine.
a sticker. The only thing I can give you is a sticker.
No, this is fine. I don't need a sticker. What I would like you to do, though, is maybe share some wisdom and experience. So here I have a very basic example of a Vert.x application, right? It runs on my fairly powerful cloud machine there. So with a bunch of cores, with a little bit of memory, so I can run this normally, right? And this is how it looks, right? So how do I get started with Vert.x? Can you let's maybe recreate the commands or something like this?
Yeah. So you start with the npm project. So pardon. So first you need to have an npm a package.json file.
Right. So
So
here it is.
So if you look at this, it's like a typical npm project. You have a name, a version, some description, and then you go on the dependencies. So on dependencies, the big difference between ES4X and Node is that we don't support Node modules. That's like a question that comes all over and over. And the reason is because we are not running on Node.js, we're running on GraalVM, and on GraalVM, we're not using the Node runtime. So it's really just the GraalJS component that we use. So the dependencies we did, well, in this example, I defined the Vert.x core because I just want to build a very simple hello world. And then there are two dev dependencies here that I create automatically, like ES4X create, which it's an utility script that will install the ES4X command that you see there later on the scripts. And this is where the magic happens. So what happens here is that when you do npm install, it will fetch the packages from npm. And when you run your application, it will also ensure that it will fetch the jars from Maven Central. Because in the end, we're running on a JVM, we need to have jars. So if you if you just run something like npm install.
Wait, I will first make sure that I use the appropriate version of GraalVM.
Yeah.
Right. So currently ES4X works on the LTS branch, which is 20.3. So I use my SDK manager, SDK-man to manage my sort of custom installations of Java. So I have my GraalVM that I install manually here. Also add that to SDK-man, but for past versions and everything, I just use that. So and then we use that Java. So now if you do Java minus version, and maybe we can make a little bit larger. So so here it is 20.3. It's GraalVM Community Edition. So there is JS. If I do JS version, I think it also comes from that. So it's all in the past. It's all good. And now what I can do what you mentioned, npm install. Right. npm also comes from the GraalVM distribution. And
it's optional. You can either use it or just use the official if you want to.
So and
but
here,
in the end, it's the same. So now is what I was saying, that some magic will happen. The magic is that it will download all the jars that are required to build this application. So basically, it downloaded the netty, because that's the library we use for network, and it downloaded Vert.x. So now it because it's installed as a dependency, it goes into node modules /.bin. Then it will
bin.
Yeah. Now you'll find the ES4X command there.
Ooh, that is very interesting. Okay, so it started.
So it says started the server on port 3000.
I didn't expect that.
Now if you do a curl HTTP or whatever, you'll see, or browser, of course.
No, I will the browser here, right? So this is the real deal, right? So hello ES4X. So our first ES4X application is up and running here. Which is Very cool. Let me make a little bit smaller this part, and then let's look at the application. Let's look at the
So the
application
application
here.
is quite trivial. There's a global there's a global object called Vertex, which is the Vertex instance, and from there you can create anything. You can create an HTTP server, like in this example, and then we specify a request handler for this server, and then the handler is just a function. So we could use it like the old way, like here, like a function, or you could use an arrow function if you like. Um,
Right. So let me
so
just make this quick test. Right. It doesn't work
you
like
need to
that.
restart. You need to stop start. It's
no worries. No worries. I didn't know if
Control
this
C.
works or not. I didn't know if this works.
There are ways to do that.
No, I'm
But
sure.
just to keep it simple, is
right. So we create Vertex is the global handler, and then that ES4X command, it will run actually the JVM, right?
yeah.
And
yeah, so it will. If you can even look at it, because there's a script. If you want to look at it, if you go on the node modules on your VS Code.
Oh, okay.
You can even open it because it's a script. If you open it,
all right, let's do
you'll
this.
see. Basically, it's some magic.
We find
building
Java
the Java command and setting all the class path.
Oh, I see.
And doing some magic like, oh, there is this JVM doesn't include JVM CI, so probably not running on GraalVM. Let's unlock the experimental features and add it to the class path. And some experiments that probably need to go away because security managers are dying on Java 17.
Well, yes. Yes. Okay. Oh, this is interesting. So you actually upgrade the module path. So you have a dependency on the GraalVM compiler.
Yeah, that will only trigger when it will only be triggered when you are running on a VM that it's not GraalVM. So say that you are running this on OpenJDK 11, then this if statement will be executed and it will upgrade the module path to have the GraalVM compiler as the default compiler. And then you have your ES4X application running in high performance mode. Because otherwise, if this doesn't happen, then GraalJS will still work on Java 8 or before, or even on any kind of VM you want. But because you cannot upgrade the compiler, it will only use interpreter mode.
Right. Well, it will try to compile, right? So the seed2 will try to compile, but it will not achieve performance levels of running on GraalVM or even with GraalVM compiler. This is very interesting. I didn't see that script before, and this is very cool that you have thought about ideas like that. It's a little bit easier to just run on GraalVM, but I understand the interest in supporting like non-GraalVM OpenJDK binaries as well.
Yeah.
That is cool. Okay, so we do that, and then we run our application, and it's all nice and swift. And then we can change that. And what are the common API that people would expect that are available here? So this is a modern JavaScript.
The common API are the Vertex APIs. The problem that I tried to solve with APIs was that when we're using pure Java APIs, your IDE will not have the knowledge of the APIs. But as you can see here, if you start doing the request.response JSON, for example, just start typing JSON. This is a request. You can see the exact methods that are really available on the Vertex API, and this comes from the first line that you see on the source code. There's this specific VS Code feature that allows you to reference types. And if you click on Vertex core, because now you can do control click or command click because you're in a Mac. Yeah. If you click there, this is what gets installed when you do npm install. It installs TypeScript definitions of all the Java APIs for you.
Okay.
And this is one of the tricks I use to get even better performance, so to say. So like before we were like wrapping in a real script, the Java APIs. But now, because GraalVM is smart enough that given just a Java class, I can just execute the methods directly. I only need to get my IDE to be smart enough to know what kind of methods are out there. So what npm installs is not really something useful for the runtime. It's only useful for the developer. It installs type definitions. If you go on the npm directly, you see huge type definition files, and then you'll see just a JS file with a mapping of classes, which is quite interesting because now your IDE, either VS Code or WebStorm, will get all this information and give you like syntax highlighting and performance on Java APIs, which you wouldn't get those normally.
Right. Let me just reiterate that because this is something absolutely spectacular, right? So you have your Java APIs, which because the Java API builds your platform, right? And you want to use those Java APIs from a JavaScript program, which of course knows nothing about the Java APIs that you're offering, because you were gluing them at runtime using GraalVM, running both JavaScript and Java in the same process. And now you are matching the Java API signatures with the TypeScript definitions. Do you do that automatically somehow? Do you generate those?
Yeah, this was kind of this is a side product from Vertex because as I've been saying, like Vertex is a polyglot runtime library. We have a very simple code generation annotation based API that we used to generate bindings for Reactive extensions, for Kotlin, Groovy. So in those specific cases, we are just like generating wrappers. And in this case, again, like TypeScript was like the hot cool thing back then. I'm like, okay, let's see how it works, and actually can work with the definitions. We don't really need to have the files themselves, and that's how how it works. So like I generate this type definitions for the whole Vertex stack, and even for classes that are not even on the stack. For example, that would be a kind of complicated example to get started, like the GraphQL, because the Vertex library is relying on the Java implementation of GraphQL, not on the JavaScript one. I just need to pass which classes from the official GraphQL library I'm exposing, and I just generate like really simple type definitions for those. So when you are on your VS Code WebStorm and doing ES4X, you see like the real types and real methods that are there.
That is very cool. That is very cool. And you install that using npm. And you also, besides, so this is one cool piece of technology that you like is sort of adjacent to the Vertex project or to ES4X projects, is this installation through not installation, generation of the TypeScript definitions for the Java API, right? And the second cool part.
Wait. Those are generated a priori. So whenever I do a release, so let's say that we are about to finish the release of 4.1 release of Vertex. So when that release is cut, I run the CodeGen tool, generate these type definitions, and then I upload the type definitions to npm. So when you do npm install, you already have them cached. Otherwise, it would take too long. So it's not like, but I could do it ad hoc. let's say that I want to generate now, like that you can, like the code gen code, if you go look at the ES4X repository on GitHub, is like the most ugly one you can find in the world, because it's like lots of it's quite yeah, it's string concatenation is like, I should have used a template engine for that, but it kind of works, and it's been stable for a long time, so I haven't really spent much time with it. So I generate those ones when I do a release.
Yeah,
So
absolutely.
yeah,
I didn't
it
mean
kind
that
of.
you run it here. Uh,
Mhm.
but this is interesting. I don't think many projects actually use something like that to expose their API to, say, the JavaScript ecosystem. I think they don't think about how useful that is, right? But the
No,
second
then
also,
yeah, that was like my use case. Like I've worked as a Node.js developer also in the past, so I know like how handy it is that you do npm install and your IDE completes everything. And then I was like doing Java code, and like, okay, my IDE doesn't know anything about Java because it expects to look up JS files. So
yeah,
that was like the process to get here.
yeah. And then the second cool bit that kind of merges the ecosystem is the thing that calls and downloads Maven artifacts when you run npm,
Yeah.
which is not something that you would expect from an npm install to do. Can you share some light on that one? And was it
Yeah.
hard to create, or was
So
it like sort of easy to create? How it works?
yeah, it is relatively easy to create because I'm using the Eclipse Ether, or I think Eclipse Ether. Like, it's like this library that is even used by Maven itself to resolve the POM. So what I do is, like, when I generate these TypeScript files, I also generate a package.json for each submodule. And on each submodule, I specify the dependencies in regards to JavaScript, and I add 3 extra keys to the package JSON. So if you go like on non-modules, where if you go to cd at Vert.x cd core, and you open the package JSON there, just the code package JSON or something like that, you'll see that there will be 1 extra key that it's not really standard on the package JSON.
Right, 1 second.
Where
My
so if you
machine
go.
is sort of dying here from all this awesomeness. Not sure. I'm not
So
sure what's happening.
you would
Why?
see if it doesn't work, it's also not that complicated. It just shows you, like, I hard code the Maven coordinates for each module on the package JSON. So what the npm install is doing when it calls the s4x command to install the Maven stuff, it just crawls the package JSON files there and reads the Maven coordinates, and it kind of fakes a POM file, and then passes this to Maven Resolver, and the Maven Resolver will tell you, well, you need this dependency, that jar, and that jar, and you download it locally. It's
All right.
like the explaining like M5 version of it.
That is something that I would expect it to be, right? But this is something that it's very good to hear that it actually works that way. I'm very sorry, my machine is melting down. I don't even know what I can close here to save some resources. It's certainly not Vertex, right? And it's certainly not ES4X, because that runs on the cloud machine. That my laptop that doesn't touch it. So just for people
Yeah.
who are watching here, this is no indication of performance of Vertex or ES4X. It's, if anything, this is the MacBook.
The
If
demo
anything,
gods are not happy.
yeah, I'm sorry about this. I will just I will ask you a question, and then I will try to
Mhm.
resolve this situation. Unfortunately, I cannot even show you on camera currently. Uh, so yes, there is this merging of two ecosystems that you run, and then you have this tooling that kind of works well with kind of enables working nicely with the API there in installation to make it familiar to JavaScript developers. So how do you, like, what's the you mentioned when you mentioned about IDEs, you said about IDEs, you said VS Code or WebStorm.
WebStorm, yeah.
So
Those
how,
are
like,
most popular ones, yeah.
can you talk a little bit about maybe the tooling for ES4X? Does Node.js normal tooling work? What is the best IDE that you think for the projects, and any particular other details that tooling related that developers need to know?
Well, currently I think the most well supported, the one that works best, so to say, is VS Code, and there are a couple of features that you can do on VS Code that I haven't really mastered how to trick IntelliJ to also work the same way. For example, with VS Code, you have like native support for TypeScript definition. So once you do the npm install, you get the code completion like you had before. That also works with IntelliJ. However, there's another trick that you can do on VS Code. If I run ES4X application in debug mode, you can attach directly with the VS Code debugger, because again, this is just GraalVM. GraalVM exposes the debugging features using the Chrome Inspector protocol, if I'm not mistaken the name. And this is like the default debugger toolkit tools for Node. So it's well integrated in VS Code. So if I run an ES4X application in debug mode, I can just go on my Node, on my VS Code, and say debug application, remote application, because that's the only way it works, because it's like using the WebSocket protocol. And then you can step, and it would be interesting to show that too, but it will take quite some time to do a demo, because then you can, when you're stepping or debugging your application, you can see the pieces of your JavaScript application, the state of your code, next to the state of your Java code. So you can see all the state, everything in one single view. I have to be honest, I haven't really spent much time trying to achieve the same on WebStorm, but I guess it should be also possible to get the same results. Are you still there?
Yeah, I am. I'm no, this is very interesting, because, like, so, and I'm sorry still for people watching just my face here. Maybe I should wait. I'm barely. we're running, just for you, Paulo, for your understanding. We are running now on half the hardware. My second laptop that I was using for some things has died, and I cannot turn it on. And this laptop is sort of dying. I'm trying to kill one suspicious process that takes too much CPU, hoping that it will just solve the situation. But if I disappear, that's I'm personally fine and healthy, but my Mac is doing some random things that I cannot predict. I don't even know what this process is. I would just love to kill it. I don't like it. So yeah, and then I think it just I don't know. Like, could it be Chrome, or could it be like a previous, like, YouTube or some
We just blame V8.
Yeah, blame V8, absolutely. Right, yeah. Maybe, like, I was trying to watch the YouTube stream that we are running. Maybe it's just the decoding something, but everything just froze and then died on me. Yeah, unfortunately I don't see the chats. If I am not even sure if we are still streaming. My device says that we're streaming at an exorbitant like on a very high data rate, much higher than usually, which is suspicious as well. But it happened. It happens. Sometimes it happens. I'm sorry, I cannot do much. Let's continue to talk about. Let's continue to talk about Vertex. What else do you think developers need to know about Vertex to use it successfully? So they know that it runs on the JVM. They know that it, for the best results, you can run it on GraalVM. Performance-wise, have you tried GraalVM Enterprise Edition?
Only a few times, because mostly because when I need to do like benchmarks, people ask like, you need to show the code, show the container. Then you cannot really upload the enterprise edition into container and say, here, there you go. He is 20% better. Well, I do see that there's better results with enterprise. By roughly like a thumb rule, I would say 10 to 20% improvements in some cases, but I haven't really been like thoroughly trying to identify which cases it get like the best performance and which places not. But I do see an overall improvement if I try to run stuff on enterprise.
That is very cool. That is very cool. And I will use this argument to try to convince people and to maybe figure out a way how the enterprise edition could be tried with some Docker images. I think that would enhance the demo scenarios and evaluation practices quite a bit. That would be cool. And it's what is very cool is that you say that you see the performance improvements. That makes me happy. That is very good to hear. It would be awkward if you would say that you've tried and nothing changes. But this is a very good information. So okay, so JVM running on GraalVM is good. Performance is good. The programming model is similar to the Node.js one, but you scale instead of by process, you scale by creating multiple instances and threads on the JVM. The tooling works. VS Code currently works the best. Maybe you can give us some hints and some pointers towards the resources. We looked at the website in the very beginning of the session. What else? Where do I go if I want to become a part of the ES4X community to the best? Can you hear me? Am I on? Am I not on? I hope I am on. I'll restart Zoom. I'm not sure. I think Paulo kind of, my Zoom crashed, I think. Quit Zoom. I will restart Zoom. Just leave meeting. Paulo will be a host. Okay. I don't think it helped very much. I'm still with you. If you are still with me, I don't hope that anyone is still with me, but this is it what it it, as they say. It what it. I cannot even kill this process, so which is surprisingly because that's kernel task. Oh my god, that is not even killable. Right? What if I quit VS Code? Maybe it's VS Code. Maybe not. I don't think it's VS Code. Quit Visual Studio Code. I cannot even quit it. Oh, this is very, very unfortunate. That is very, very unfortunate. That is super unfortunate. Right. Okay. What we can do? What can we do? We cannot do anything. We cannot do anything. The life goes on. Let me just try to make the best. Was trying to apologize to Paula. Yeah, this is I am the host, no? No, I want to. Right. This is everything has died, which is so unfortunate. Trying to log in to the Zoom with my phone just to say sorry to Paula because he's still on the line and he's still waiting. But I don't think it is possible to resolve the situation now, which is very, very unfortunate. So I am very sorry if you are still watching. I'm sorry. If you're not watching, lucky all of us, and we will cut this out of the video later. But I think this is what we need to do, and we need to stop the stream because I don't think this is. I don't think anything is happening with the situation as is. So, yeah, I'll say sorry to Paulo, and I learned a few things. I am very sorry that the finish got so crushed. Thank you for watching. Stay tuned. Join the Slack. Don't join the GraalVM Slack channel, please, and then when we will transpose this information into a more viewable and reasonable format, we're gonna try to post the update there. Until then, thank you very much. See ya.